Welcome to ExcelWorks video tutorials. The title of this presentation is How to Solve an Equation System in Excel and Google Sheets with the function NLSOLVE. NLSOLVE is based on Levenberg, Marquardt, or LM. Is a versatile solver in Excel for solving a variety of problems. You can use NLSOLVE for finding exact or minimum error solutions to a system of algebraic equations, including inequality equations. You can find roots for nonlinear equations. You can solve least square curve fitting problems or nonlinear regression problems. You can combine NLSOLVE with other calculus functions to solve parameterized optimization problems, including parameter estimation of differential equations and many other calculus problems. Let me begin by introducing the function NLSOLVE. NLSOLVE takes only two required parameters. The first parameter is a reference to the equation's formulas, and the second parameter is a reference to the equation variables. It also takes two additional optional parameters. If you have inequality equations in your system, you can pass the number of inequality equations in parameter number 3. And if you would like to change the algorithm parameters, you can do that via key value options in parameter number 4. Unfortunately, NLSOLVE is not a standard function in Excel or Google Sheets. To enable NLSOLVE in Excel, you will need to install the ExceLab calculus functions add-in. If you're running Excel on a Windows PC, install ExceLab 7 from excel-works.com. If you're running Excel on an Apple Mac, install it directly from the Microsoft App Source. In your Excel ribbon, click on Insert, Get Add-ins, find the calculus add-in and add it. If you are working with Google Sheets, install it directly from Google Marketplace. I will be demonstrating the use of NLSOLVE by solving a number of equations. The first example is a two-equation system as shown here. The second example is a three-equation system with one of the equations being an inequality. The third example is a more interesting calculus problem. We have an integral with two parameters a and b. We will find the values for a and b such that the integral has the value 8 and 1/3. For this example, we'll be employing the integration function quadf and NLSOLVE to solve this problem. I'll do the demonstration in Excel, although the procedure for solving these problems in Google Sheets is virtually identical. I started Excel with an empty book and copied the problems for reference. The first problem involves solving for the variables x1 and x2 in this badly conditioned system. So it's convenient to work with the row cell addresses x1 and x2 here to define our formulas. The formulas must be defined with respect to 0 on one side. I'll begin by defining my first formula, equal 10 to the power 4 times x1 times x2 minus 1. And the second formula, I can now define my NLSOLVE formula. My first argument is my equations, and my second argument is my variables, range x1 to x2. I'm running in ExceLab 365, so I'm going to take advantage of the spell feature by simply pressing enter. NLSOLVE will calculate the solution and expands into neighboring cells. NLSOLVE took 16 iterations and produced an accurate solution with a sum of square errors on the order of 10 to the minus 32. Let's do next the second example. I'll again type my formulas with respect to 0 using the same variables x1, x2 and x3. The second equation, and the third equation. Now again I'm ready to define my NLSOLVE formula, passing my equations and my variables x1, x2 and x3. Now one important fact here is since I have an inequality equation in the system, I have to tell NLSOLVE that the third equation is an inequality equation by passing the number of inequality equations. In this case it's 1, and also I have to list that equation as the last equation in the system. Now I'm going to press enter, and NLSOLVE will calculate the result and spell into neighboring cells. It took 8 iterations and also calculated a very accurate solution with an error on the order of 10 to the minus 30. The third problem is a parametrized calculus problem. We have an integral with unknown limits, and we want to calculate the limits that will give us a certain value for the integral. I'd like to begin by defining named variables for my limits a and b. These are my labels, and I'm going to use the name manager in Excel to define names for the limits. So I've named cell B1 as A, and I'm going to name cell B2 as B. Next I'm going to write my integrand using x1 as my variable. I'm going to assign some initial values for my limits, 0 to 1, and I'm going to integrate my function between these limits using the integration function quadf. So this is my integrand, my variable is x1, and my limits are a to b. So the value of the integral is 1.6. This is not exactly what we would like it to be. We would like it to be 8 and 1/3. So in order to use NLSOLVE to calculate the limits for us, I'm going to define a constraint which measures the difference between my actual value based on my guess values for the limits minus my desired value, which is 8 and 1/3. I'm ready now to use NLSOLVE to find the a and b that will drive this constraint to 0. My first parameter is my constraint, and my second parameter is my variables, which are a and b in the range b1 and b2. NLSOLVE calculates the solution for me almost instantly. It takes 32 iterations and calculated an exact solution, and the value for a and b should be -2 and 3. So now if I take these values and copy them over my guess values for the limits as numbers, you can see now I'm getting the exact value that I wanted for my integral in cell A5. I performed the previous examples in ExceLab 365, which is the same as Google Sheets as far as running array formulas with the spell feature, but if you are using ExceLab 7 on Windows, the spell feature is not available, and you will have to run NLSOLVE in a pre-allocated 2-column array by pressing Ctrl-Shift-Enter. Let me demonstrate this for you quickly. I'm back in Excel, and I will demonstrate how to run NLSOLVE as an array formula. You will need to do this if you're using ExceLab 7 on Windows. So to do this, you would have to allocate your output array, and then in your formula bar you will click and type in your formula, and now instead of pressing enter, you will press Ctrl-Shift-Enter at the same time. See, now Excel will place curly brackets around your formula to indicate that this array result is an array formula. Next, I would like to describe some optional controls for NLSOLVE. Not every problem has an exact solution. NLSOLVE will try to calculate the best minimum error solution, and you can tell how well it did by examining the value of the sum of square errors in the variable SS error in the output solution. If the SS error is a large value, it means that NLSOLVE was not able to converge. So there are a number of things you can do. The first thing you should do is define different starting values for your variables. Simply go to these cells and assign any values other than 0. If it does not help, this is usually the most effective way to get a better solution. If starting from different values does not help, try to relaxing the tolerance and changing values for the factor control key, and you do this as shown in this formula here. You may also try relaxing the Jacobian step. Also, this may not necessarily yield a better solution. In this presentation, we described the use of the NLSOLVE function in the ExceLab calculus functions add-in, which contains a dozen other calculus functions which can solve integration, differentiation, interpolation, and differential equations as well. If you're interested in any of these problems, check excel-works.com for examples. Thank you.